it's feed as in a feed of data. I might, does he have a bunch of copies of this?
Yeah.
I might have to steal this. Also, I like how they lay out the pages, that there's not a lot of text on one page.
You know, at the end of each chapter, it like does a
I like
bunch
it.
of ads.
And then we're also reading the Giver in actual class.
Oh yeah, the Giver you just have to, like,
I've
class
already
it.
read it, but I'm reading it again. So
Alright, so the little counter in the bottom left-hand corner, right, counts how long we've been in here. I bet by the time that thing hits 20 minutes, we can be done with the 412
what's
lesson.
the one that says 4.42?
Yeah, how long the video's been recording. And I bet we can actually jump into the next lesson too, because of how much you guys actually retained from yesterday that you felt real stressed out about. But I bet you're actually better than you think you are. You're totally better than you think you are. So we're going to be using a lot of area models, so if you want to go ahead and sketch a few area models on your paper, that is what we're doing today. So if I was you, I would like hamburger and then hamburger again and just have like 4 sections or something like that, or just fold your paper in fourths or something.
Oh, this is going to be our entire paper.
I mean, it's our notes for today. So let's reactivate your brain from last night, or from yesterday's class, I guess more so. Go ahead and put that area model on your paper. We're not worried about the quadratic would look like in standard form, but if we wanted to put it in standard form, we would just put the x values together. You do not have to put it in standard form. What you do need to do is factor this. Figure out what are the dimensions. Now, the other thing we're going to look at that you can start thinking of is Casey yesterday said that the cross products of an area model rectangle are always going to equal each other. So we're also wondering, is that holding true? And we found this to be a true statement that we can actually use.
What is that supposed to do?
A true
Anything
truth?
other than just saying it does that? Like, does it
How do we
show anything? Because I forget.
Don't worry, we're going to piece it all back together.
Okay. Forget why.
Sure. I mean, whatever, however you lay things out, we're going to do some diamonds, but mainly we're going to do area models today.
Just one area model in each square.
Yeah,
I
probably.
just
I mean, whatever works for your paper. Most of the values we're working with are just double-digit coefficients, if anything.
Okay. It's the x squared and the x's.
Oh, I forgot if I use the cursor, it doesn't go straight. So what's funny is if I use my finger, it will straighten things out for me. (10x squared). Okay, well, when I look up this way, what's a factor that 10x and 35x could share? 7. 7 is not a factor of 10,
5.
but 5x could work. And if that's 5x, what does this have to be?
2x.
If that's 2x, what does this have to be?
-2.
And if that's -2, what does this have to be?
-7.
And does it work?
Yeah.
Yes. So our binomials here are 5x minus 2 and 2x minus 7. Any questions on that? Now we could have also looked this way and said, what common factor does a 10x squared and a 4x? I would ignore the negative because we already know. Yeah, 2, right? We could identify they're both even. They share a factor of 2. So there we go.
Wow. That was simple.
So then we want to check Casey's hypothesis. Casey thinks anytime we have an area model that is set up correctly, the cross products will equal each other. And really what she's testing is that 10x squared times 14, well, that'd be 140x squared. What's -35 times -4? 140. X times x, x squared, right? This will help us because this is the actual b value in the quadratic. So when we break it up, We're looking for what factors will multiply to make your 140, but also we have to make x squared, and then when they add, they make my actual b value from my quadratic. But that's if we were working in standard form to start, which we weren't. We had the area model already given to us, so we already knew how the b was going to break up. So according to Casey's model, that does work for us. Now, if you need to write this down to remember it, which I don't really think you'll probably have to, but if you aren't yet comfortable remembering, oh yeah, that's a quadratic, please take a moment and write down the word quadratic. Now, a lot of people will be like, quadratic, quad, 4, right? Not really. Quadratics are normally given as trinomials. Sometimes they're binomials, sometimes it's a monomial. The parent function, and this is what you do need to know, the parent function of a quadratic, anyone know? Parent functions are always the base where we start. So where we start, the original quadratic, is x squared. The standard form that we're used to, so you may want to write down standard form, because there are other forms too, is a x squared plus a bx plus a c. Our bx often will be broken between the outer and the inner, as we looked at the old school FOIL method yesterday. So if we had 2x squared, 5x, and 3, and we wanted to try to figure out an area model for it, what we're actually looking at, right, is the physical area model of this. This is the problem with me operating on Smartboard. I can't click that hyperlink. Got to come over here. So we have 2x squared, 5x, and 3, right? 2x squared, 5x, 3. What we're looking for is how can we put these together in a rectangle that we can then factor. So if I link those up, and then we know the 3 are going to be like out here, right? Either stacked on top of each other or stacked out. But we don't want to leave a gap because then that wouldn't be a whole rectangle.
So that would work because you get 3 on the bottom and 2 on the top.
Ah, we can put 3 here, 2 on the top, double click is rotate, single click is flip the sign. So now we're able to figure out the dimensions of this, and we're able to figure out the split. So if we try to do this as an area model, we split the 5x to 2x and 3x, right? So let's go ahead and write that down. And I should have split this page a little bit differently. So I'm actually going to add a page here. If we draw that in the algebra, like just our area model, not actually draw the tiles, we had 2x squared, right? We had 3, we had a 3x here and a 2x here, leaving this as a 1 and an x, and 2x is wide, and 3. Does this make sense that the area model rectangle that we write down is a direct translation of the physical area of the objects we had? I never understood that. Serious. Like, trying to help you guys appreciate like where math has changed with how we teach it. I literally never understood that the quadratic that we represent right here, right, 2x squared plus 5x plus 3, was a tangible object that we could look at. I never understood that. So here we go.
Is that why they had us do everything with those algebra trials?
And with the diamonds and area models, all the way back to like 6th grade content. All right, so try that with 3x squared plus 10x plus 8 if you need. Grab some algebra tiles, but we already know that the 3x squared has to be together and the 8 has to be together. It's the 10x that will split. So draw an area model on your paper if you need another one.
Are we basically doing?
I'm extending this a lot.
Are we basically doing what we did with the first one?
Yes. But they went ahead and like filled in the 3x squared and the 8 because we know that. The ax squared and the c always stay together. The b value is what gets split. Now, there are two different ways to do this, right? Because the values that you put for the split b can trade places, but that would also then make these values trade places and these values trade places. So there are multiple ways to do this. Don't think that if you're doing it differently than the person sitting next to you that you're wrong. The one thing I miss is being able to right click. The smart board had a right click, and I don't know if this board does. Yeah, I'm testing. Don't watch me.
Okay.
Don't watch me. I'm testing.
I
Wait, were we supposed to use it with the diamond problem?
Ooh.
What? Okay, I think I got it.
If we
Because
just start guessing and checking,
because
right? I want to go through the like, oh, womp, 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 sad trombone, and then we'll get to the better method. If I just start guessing and checking, right? If I put a 1 here, this ends up being 3x, and then this would have to be 8, and that doesn't work, right? Because this would end up being 8x, and that's 11. So then I could go back and I could be like, well, what if this is a 2, right? And I still have my 3x and my x, and this would then be 6x, and this would then be 4. Ooh, okay, so now I got it, but it took me 2 guesses of like, how do I get there? The more efficient way is to do what? How do I do the diamond problem?
So you put the ax squared times the c.
Yeah, cax squared if you want.
Cax squared on top and the ex on the bottom.
And 10x then. Now here's the thing that throws people off. Neither of these numbers exist in the rectangle.
Yeah.
They are pieces that come from the product and the sum. Right? So now we say what sums to 10x and makes 24x when we produce it? 6 and 4. Right? You can easily in your head figure out 6 and 4. And then since we know those are the numbers, all you got to do is plop them in and then figure out your factors. And it's much easier that way once I've decided. Now, I could put my 6x up here and my 4x right here. And if that's the case, then the 3x would go down here, the single x would go here, the 2 would go here, and the 4 would go here. Notice what I meant about everything just switches. Right, but I was just trying to get you to see it. They all just trade places, which is what I drew up here, which kind of looks messy too. But that's so you might solve it green way, you might solve it purple way, like they're the same. Make sense? So do that for 2x squared plus 7x plus 6. Sorry, I know it's kind of sloppy up here, and this page is going to be the longest page ever because I just keep extending it.
Wait, so it's 2x
Squared plus 7x plus 6. If we take Casey's method and diamond problem at first, it will make our life easier. So you should write this down on your paper, by the way, so you know what you're working with. 2x squared plus 7x plus 6. What you never realized, because there was no reason for you to realize it, is all of those lame diamond problems. You're like, this is so easy. I'm trying to think of factors of 12 that add up to 7. Duh. or 4 and 3. Like, and I get this attitude from my 7th graders taking Math 8. And they're like, why are we doing more of these? This is such a leap forward in solving the quadratics compared to just a guess check method. This is amazing, right? Because then it lets us know 3x and 4x are my values. I can then set up the diamond, or sorry, the rectangle. I already did the diamond. 2x squared and 6. I always put those in first. It doesn't matter where you put the 3x and the 4x. Because if I make that weird choice, everything will trade places, and my binomials, my dimensions will come out the same. So, I look across, right? 2x squared and 4x, what do they share? A 2x. So then this must be x, meaning this must be, check that they all work, and then we write out our factored form, x plus 2, 2x plus 3. Any preguntas? Questions in Spanish? No tango español. I know half Spanish.
I know how to say it.
Yeah, we already did E because I overteach and I jump through questions and I want us to go fast. Because we can, and there's no reason not to.
You just break our minds.
This is
going quicker.
This is one of my favorite classes, not only because you guys rock, but because there is nobody sitting there like bored sketching. I let my other classes, like if you get done with the problem and you want to draw or whatever, like because there's only 5 of you, it's real fun to like. We can go more quickly, and I'm trusting you guys to stop me if you're confused. So everything we just did, let's do this independently. Work through this. 6x squared plus 17x plus 12. Please write down the trinomial first. I'll even do it. No talking, just try to do it on your own. Do the diamond, then the rectangle, then write out your factored form. I seriously want to go back in time, to my high school math class with like AJ and Seth and all my friends back then and show them this technique. I guarantee there would be some swear words exchanged.
Wait, what?
Because the old method of us doing this was just like, I don't know, try it. They would have you take the trinomial, write out the parentheses, and literally guess check. They would say, okay, try 6x and 1x. What could possibly work? If you can't find anything that works, okay, try 3x and 2x. Like, we literally just went through as many iterations as it took to figure out what worked. But instead, because we can use this cross-product knowledge, we don't need to guess check. We can solve it in a clean manner. What goes on top of my diamond?
72x squared.
And on bottom is the 17. Factors of 72 are kind of weird. Excuse me, it would have been funny if the 6 and the 12 just worked to make my B, but it doesn't. So 5 doesn't work. 4? 4 could work. 8? 8
I did
and what?
8 and 9.
Oh, 8 and 9. I forgot about those guys. So 8 and 9 add up to 17, and they multiply to 72. So then it doesn't matter how I set up my diamond, or I keep calling this a diamond. Doesn't matter how I set up my rectangle except for the 6x squared and the 12. Please always double check that you put a square here. It probably won't mess up your work, but this is a mistake I see a lot. Kids are working fast and they forget to put that squared there. So,
Too many squares. And then, like, wait a second, nope.
wait, that's not a square.
Why did you put 12? Wait. Oh, yeah. I was thinking 17.
So be careful. That's why before I would do the diamond, I would go ahead and draw this and put in the a and the c squares. Or rectangles, whatever. Yeah. Now yes, but like I just said to Liam, I would draw this and put this, like fill in these two squares first. Because the other mistake I've seen is kids will accidentally plug in either the 72 or the 17 over here. Neither of those numbers go in the rectangle. Only these numbers go in the rectangle. So then 6 and 8, well, they're both even, probably 2. Which means this would have to be, and this would have to be, and this would have to be, and it works. What?
Wait. Oh, sorry.
The x comes from over there. Now, is there any way that there would be an x here or an x there?
No.
Not when we're working with x squared plus x plus a constant, but if we're working with some kind of situation that involves like xy, instead of x squared,
You'd have like an xy.
we might end up with weirder, like, so, but that's not quadratic. That's a whole different malarkey.
What is it called?
So then we write this out. Don't worry about it, I'm not even quite sure offhand. It's just polynomials, just weird polynomials.
Boy.
So 3x plus 4, 2x plus 3. Now let's ask a question that doesn't really matter at this point, but we might as well think about it. Can I switch these?
Yeah.
Like, could 3x plus 3 and 2x plus 4 work the same? No. Because we have a 3 here and a 2 there.
No.
If we just had x plus 4 and x plus 3, then yeah, we could switch them because literally you're changing the binomials. But when we have coefficients on the x's, the constant locations really do matter.
Unless you change 3 and 1 and 2 and 3, then it's...
Yeah, unless you do these also, which would just be kind of dumb.
Yeah.
Yes,
So,
Sophia?
like, on the other thing about, like, could there be an x in the spot? So what if you had, like a y plus an x? Would that still be, like, the quadratic expression, or would that be different?
No.
I don't know. It all depends on what we're working with.
Oh, boy.
Math.
Now, have I... I'm really scared. No, let's get through this lesson first. I did not make my 20-minute goal. It's okay.
No.
We've kind of taken our good old time. So this is what we just did, right? 6x squared plus 17x plus 12, and that's the end of the lesson. So we almost made the 20-minute goal.
Close. You are
Right.
about 3 minutes.
So I would like to, because I want to start looking at some more of those interesting situations. No. So you do not need to do both homeworks. Your only homework that is assigned today is the 412. But if we can get a little bit of a head start, then we'll probably be able to take a work day during class and like catch up. So don't worry. I mean, if you have time, sure, go ahead and do it. We just want to keep practicing factoring and getting more comfortable with these together. Because then your homework will be even more easy when you've done a bunch of these.
Oh, yeah. Oh, are we
So
doing
we're going to move on and keep working on like lesson work. We got 20 minutes left. I'm going to keep teaching. So,
Get 20 minutes of homework.
hey, the other thing is, I might, if possible, on Friday, if we don't have to have class together, I might take that time to go do other stuff and prepare for the pumpkin drop activity.
Wait, is
So,
the 7th grade
like,
gonna do
if
that
you
too?
don't need me as your teacher, I just give you work time or something like that. So, try ABCD here on your own. Let's see if any of these give you trouble and why they might give you trouble. So I would set up diamonds and rectangles for each of these, but please write out the original first.
Like, you always put, like, the x squared and the 9 into 2 of the boxes.
Yep, the bottom left and top right. Or you could change their locations, but it's just going to change what the diamond comes out to look like.
I'm trying to run out of space on the front.
While you're doing that, I'm going to pull up a gift for you. My 8th graders from last year ended up loving this song so much that they would sing it to each other. It's a trap.
So if it's the same equation, would you write it as squared or would you just write it out?
You can do either way.
Would you write it as like
The cleaner way to do it, like, so which one are you talking about?
So
A is what?
it's x plus 3
times
squared.
x plus 3.
So the cleaner way to write it is x plus 3 quantity squared. This song is so fantastic.
Oh, I love that.
Beautiful.
That one's so good.
Have you heard it before?
No, I just.
Oh, you'll. As soon as you hear this once, you will recognize that intro anytime we listen to it.
Oh no, I'm
So, all of these quadratics are quote-unquote easy quadratics. They, if we try to look at them in a physical representation, make a perfect rectangle. But there are situations that aren't as nice. They don't make a perfect rectangle, and therefore factoring it does not come out to give us integer values.
Oh boy.
When we hit a situation like that, we have to use a fancy formula called the quadratic equation or the quadratic formula. And really, quadratic formula is probably more correct because it is the formula for how you derive the zeros of the parabola. Are any of these giving you struggles? Now here's the funny thing. I guarantee high school Micah, like 10th grade me, would have struggled with each and every one of these. It would have at least taken me a lot longer than you. Because I didn't have the technique.
Let's promise Mr. Hudson will go over the time machine and go back.
Okay, let's make a deal that if you make a time machine, you will come back to October 23rd, 2019 at 11:07 a.m. Okay, can we make that deal? So if you make it, you'll be here in the next minute. You'll be here. You'll show up. We'll know.
That's not how Marvel says it. Is that how Marvel says? Marvel says it doesn't change the future. It makes a new timeline.
Yes, you are the splits of the timelines. Yes, you are correct. There's just a scene in a show I watch where they're talking and they're like, wait, let's agree that if we make a time machine, we'll come back to this moment in time 10 seconds from now. And they're like,
9, 8.
it was Big Bang. It's on Big Bang TV. Sheldon and Leonard. So it's in the roommate contract. That literally he signs the roommate contract, and in the contract it says if you make a time machine, you have to come back to this moment, and they wait, and then they're like, oh well, that was disappointing.
Like, cause he didn't make it.
Any struggles on ABCD?
Oh, I haven't finished.
How do you like get negative?
Who?
Do one positive and a negative.
Yeah, but like.
I love the question. I knew that somebody would eventually get to that point of like, wait a
I
minute.
hadn't even gotten to that point on C.
C. So we have negative 7x squared, which if we're going to multiply and make a negative, we know one has to be negative, one has to be positive. We also then add up to 5x, which means they're going to fight each other. Who needs to be bigger if we're going to fight? The positive. Because it wins by 5.
So should it be A and negative?
But it had to put 7's like a prime number.
Wait, no, hold on.
But it
It has to be 7 and 1.
7's a prime.
Is that even possible?
Yeah, no, you can use decimal.
Wait, whoa.
If I make a time machine.
Usually,
What
what is
just
like opposite dating from
So are we not even gonna do
I
that
just-
one?
Oh no, it's getting stuck in my head.
That's great groundwork here.
If you try to solve a quadratic equation, I promise you it's possible without any frustration if you take everything.
He's not American.
Solve by x squared, x and the rest. Alright, now take the coefficients, name them A, B, and C, and if you know the right formula, you will see that you get the solution in the very next step. Just sing the song in your head.
Negative
A plus
or minus the square root of b squared minus 4ac all over 2a.
We should all do it before.
plus or minus the square root of b squared minus 4ac
over 2a.
Okay, let's solve our equation. And the job is
Alright, so for real then,
this now for x.
let's say you have a quadratic that's really
Multiply
gross.
by 4a, and if you now add b squared,
This is the algebra that's
The point
happening.
is here. Just take a close look to the left side and you see there's a binomial formula with 2ax and b. So altogether this is the square of 2ax plus b, and now we have only 1x. So the next step would be to get rid of the square. And if the right side is not negative, the square root must be one solution. But as an alternative, because minus the square root yields the same if you square it. So we write plus minus, and now we are at the point where it only takes 2 more steps to solve it.
He's just rattling this off.
You know what will be next. Subtraction of b and division by 2a is given.
Alright, so for real, this is a very, very, very well-known formula in mathematics that is annoying to memorize, but the song can actually help you. So please, on your paper, write down this.
Whoa.
X
So we don't
equals,
have
not
to
the whole
do
thing,
all that.
x equals, make a big fraction, negative b. Plus or minus symbol, literally saying there are two options. You can take the positive route or the negative route.
So that symbol means plus or minus.
Yeah, plus or minus. Radical, so square root. B squared. If your b value is negative, it will come out positive because we're squaring whatever the b value is. Minus 4ac. All over 2 times your a value.
What is this?
This, you can label, is the quadratic formula.
Oh, is that what you wanted to show us?
This
so then we can use it.
Will derive any quadratic formula.
Wait, will we be using this here, or are you over teaching?
No, we're using this year.
Wait, didn't Mr. Holland talk about that? I remember
Probably.
saying something about like a crazy equation.
Yeah, but she was like, you don't need to
Now,
know until like.
One of the other reasons that I like this video is, the pretty landscape behind it. But literally, this is the derivation, like how we derive, of the quadratic formula. It's not just something behind the curtain with, like, a machine, whatever, making a, shoot. What's the movie? Yes, Wizard of Oz reference. The dude behind the curtain that, whatever. Look, here's your start quadratic. What do we do on both sides? We take away the c. What do we then do? We multiply by 4a just because, right? Because we can do anything we want to algebra. Then we add b squared on both sides. Why? Who knows? Then we clean it up, right? A whole lot of cleaning up, and we factor that this is actually a perfect square. It's 2ax plus b squared on the left side. You don't have to understand all this. We're just walking through how this came to exist. Then they square root both sides because we're trying to isolate this x. So we got to get rid of the square. Now we're here, get rid of the b, subtract it, get rid of the 2a, divide it. That's how all of this came to be.
Well, that's how they got
Came to be. Oh, I didn't plug in the USB.
That's a formula for x, okay? And it's negative b
Plus or minus the square root of b squared minus 4ac all over 2. I never sing that fast enough.
negative b plus or minus the square root of
He's like on a castle or something. Like, I don't know where he is, but he's pretty sweet. Uh-oh. Key change.
Yeah.
This is hard over and over again.
Guys, this is what
Negative b
this is what we
plus
have
or
to do
minus.
whenever
All right,
we do our math.
let's try this then. Right,
This
if
is
that's
what we are applying.
our quadratic, if that's what we have, let's try this.
Oh no. Do
So,
we have to do all the steps, or can we just go straight to this?
so we write out negative b plus or minus the square root of b squared minus 4ac over 2a. You gotta sing. So, negative b, the opposite of our b value. Okay, negative 5. Please write this out with me. Plus or minus radical b squared. We can go ahead and write in 25 if we want, because that's your b squared.
Oh my.
Well, I know, because it's catchy.
Wait, where did you where's you getting the numbers?
This is b squared, right?
The one
A,
that you had a hard time
b, c.
Okay, yeah.
So now clean up a little bit.
Yeah.
This comes out to be negative 28, but then plus, right, because minus a negative. So this is 25 plus 28.
Okay.
So this comes out to be radical 3, right? No. Sorry, that was if one. That was still if one was positive, one was negative. Both positive. 25, 28, 53.
Over 2. So,
Now, those of you with a graphing calculator, or actually the multi-views, I think can do it. The easiest way to do this is type it in, but then go back and change the plus to a minus. So when I go to type this in, make sure you use the negative. But I'm going to first do quantity. Right? I'm going to open up parentheses, negative 5 plus the square root.
Guys, we have to like use
You
the
can-
form, guys. Yeah, we use your finger for form.
No, but like it's hard to match his pick. It's so weird.
I mean,
And
but
it's
you
weird.
don't need to.
But it's really auto.
So he is, he's not American. I forget where he's from. No, he's like,
That's it.
yeah,
No,
like,
no, that's-
or Finnish, maybe.
Yeah,
Like,
yeah.
he's probably from Finland. So if you can see, I like put the entire numerator in a set of parentheses,
it's like
so
about
then you can divide by 2.
1.14.
Right, but then if I do second entry, this will convince you to buy an 83 if you don't own one yet. It copies my entry I just typed in, and I can just change the plus to a minus
Oh.
and find the other value. So our zeros here come out to be x equals 1.14
Yeah.
and
You're gonna need to teach me all the stuff on the graphing.
negative 6.14.
Because I don't know how to do like.
Wait, is that a graph?
Those are our zeros.
I don't know half. the
That
letters
is
on the
where
graphing
we
calculator.
cross the x-axis.
Oh, where you told us last time. Okay, yeah.
Now-
All this just to do this thing.
This
Oh my gosh.
is over teaching for today.
I like this.
For
It's
today.
not over teaching
Wait.
for the year. We're
Wait,
gonna use the quadratic. But all I wanted to show you guys, all I wanted to show you guys was not every quadratic can use the diamond and the rectangle. When you find a situation that you're like, this just won't work, it probably won't.
So you.
That isn't one of those you did something wrong. It probably doesn't work with integer values. And that's when we have to use the quadratic. With that, we only have about 1 minute left.
Oh my gosh.
All of 2a. It's not all over, it's just over 2a. That's the problem.
What's all of this right there?
This song is catchy. No, listen to the intro. The intro is so catchy. Are there like different versions of the song?
It's like the string picking kind of is like what it sounds like at the beginning.
I promise you, it's possible without any